Hello, gentle dreamers, night thinkers, and cosmic wanderers. Welcome to Sleepy Science Stories. This is your time to slow down, to let the noise of the day drift away, and to settle into the quiet rhythm of thought. Tonight, we're going to drift together through the soft darkness of interstellar space to meet a visitor who came from the stars and stayed only for a whisper of time. Its name was 3I Atlas, and it passed through our solar system like a ghost, silent and unhurried, a stranger from another Sunday. Before we begin, take a deep breath. Let it out slowly. Feel the air leave like stardust settling after a journey. This isn't a race to understand the universe, it's a gentle glide through it. If you're new here, welcome to our little corner of calm curiosity. If you find peace in these quiet science wanderings, a soft tap on like and subscribe helps others find their way to this sleepy galaxy too. And to everyone already drifting with me through the cosmos, thank you. It's your quiet presence that keeps these stories alive. Tonight's tale isn't about roaring rockets or blinding explosions. It's about silence, the kind that hangs between stars. It's about a traveler that wandered into our neighborhood for the briefest moment, carrying secrets older than the Earth itself. So close your eyes if you'd like. Let your breathing match the slow pulse of the universe, and imagine a dark sky stretching endlessly above you. Somewhere in that stillness, a tiny light moves faint, calm, and impossibly far from home. This is the story of 3I Atlas, the silent visitor. Far from the light of the sun, in a place where darkness feels almost solid, something small was moving. It was not rushing, not tearing through the void, but gliding through it as though it had always known the way. The stars around it burned quietly, ancient and indifferent, and among them drifted a faint speck that no one had seen before. This was 3I Atlas, a fragment of another solar system, an interstellar visitor crossing the long gulf between suns. It had been traveling for millions of years, perhaps longer, leaving behind whatever world had once been its home, and moving through a sea of nothing. The space between stars is not empty. It is full of invisible threads of gas, grains of dust, and forgotten pieces of creation. 3I Atlas had passed through all of it, carrying a record of its journey written in the scratches and scars of its surface. When it entered the outskirts of our solar system, there was no announcement, no flash of light, no tremor, no warning. It arrived the way most cosmic things do, quietly, without ceremony. A telescope caught it almost by accident, a faint streak across the sky that seemed to ignore the usual rules of orbits. Astronomers who looked closer noticed something peculiar about the way it moved. It was not circling the sun, but passing through, tracing a curve so open that it could never loop back again. That was when they realized that this was no local rock. It was a traveler from another star, the third interstellar object ever found, after Oumuamua and Borisov, each one like a rare visitor from a different corner of the galaxy. To imagine 3I Atlas is to imagine something small, perhaps no bigger than a mountain, but carrying the history of an entire system within it. Its color was faintly reddish, the kind that comes from long exposure to radiation and the slow cooking of cosmic rays. That hue tells a story of time so vast it almost resists belief. The reddish tone means that its outer layers are covered in tholins, complex organic molecules formed when sunlight, or in this case starlight, breaks apart simpler ices like methane and ammonia. In the space between stars, there is no warmth, no protection, only the slow, unending drift of particles and light that carve and darken whatever they touch. The surface of 3I Atlas was not smooth or gleaming, but pitted and ancient, a relic shaped by loneliness. As it approached the sun, the faint warmth began to wake it. Perhaps it had once been a comet, its core filled with frozen gases that could evaporate into delicate jets. Perhaps it had been dormant for so long that even the sunlight could not stir it fully awake. Some telescopes caught hints of a thin, fragile tail trailing behind, not as bright as a comet's, but they're all the same, a faint mist of dust slipping from its surface. It was as if the traveler had begun to sigh, shedding what little it had carried across the interstellar void. In its quiet way, 3I Atlas was coming undone. No one knows how long it had been wandering before it found us. The galaxy is full of stars, and each one has its own collection of planets, asteroids, and comets. When those systems form, pieces are often thrown out, flung away by the gravity of larger bodies. Some fall inward and are consumed by their suns. Others are cast outward with just enough speed to escape entirely, sent drifting into the dark. 3I Atlas was one of those castaways. It had once belonged somewhere, had once circled a sun that may now be long gone, and then one day it was pushed out forever. It crossed the cold plains between the stars, a lonely grain of matter among billions. When it reached us, it did not stop. It simply curved around the sun and continued on its way, bound for another endless journey through another stretch of quiet. If you could have seen it from up close, it would not have seemed alive. It would have looked like any other rock, silent and cold. Yet there is something deeply alive about the idea of motion that never ends. To move forever, to carry the dust of ancient worlds across the empty dark, is a kind of persistence. 3I Atlas may never pass another inhabited system. It may never be seen again. But for the briefest moment, as it glided through our corner of the galaxy, it became a reminder that even in the vast stillness of space, there are travelers, and sometimes they find their way to us. It came silently, it left silently, and between those two silences it told us a story about distance, endurance, and the quiet beauty of things that wander. The story of 3I Atlas truly begins with its name, a sequence of symbols that sound almost mechanical but hide something poetic within them. The first part, 3I, is simple in its meaning. It stands for Third Interstellar, marking it as only the third known visitor from beyond our solar system ever to be discovered. Before it came, there were two others, each of them slipping quietly through the sun's domain and vanishing again into the dark. The letter I became a kind of badge of honor, a sign that the object was not one of ours. To earn that single letter, an object must follow a path that no orbit can hold. Its motion must defy the sun's grasp and promise that it will never return. The second part of its name, Atlas, is a tribute to the telescope that first caught sight of it, the asteroid Terrestrial Impact Last Alert System, perched in Hawaii with its watchful eyes scanning the heavens for anything that moves in an unexpected way. The Atlas survey spends its nights photographing huge stretches of the sky, searching for faint smudges that shift from one image to the next. Most of those smudges are asteroids, small and familiar members of our own solar family, but sometimes something else appears. When the faint light of 3I Atlas crossed its field of view, the telescope was only doing its usual work, gathering light from a sky that never truly sleeps. A few pixels on a digital image flickered in a way that caught attention. A pattern in the data hinted at motion that did not belong. The object was moving too fast and at too strange an angle to be one of our own. Astronomers compared its path against the library of known orbits, tracing it backward and forward through time, and soon the truth became clear. The sun could not hold it. Its path was not a circle or an oval, but a vast open curve that came in from the deep dark and would return there once again. That shape is called a hyperbola, the mathematical signature of freedom. It is a path that bends under gravity's influence but never loops back. It is the trajectory of something that passes through only once. That curve is how scientists know when an object is interstellar. It is not bound to our star, it is bound only to the galaxy itself. The name Atlas feels fitting in more ways than one. In myth, Atlas was the Titan condemned to hold up the heavens, a symbol of strength and endurance. This little rock, though far less grand, carried its own kind of burden. It bore the weight of time, of distance, of silence. It had held that silence for millions of years before the faint touch of sunlight reached it again. The telescope that named it did not know its story. It only recorded its presence, a trace of brightness on a digital screen. Yet, in that simple act of recognition, 3I Atlas became something more than a wandering rock. It became part of our story too. Names have a quiet kind of power. They are how we tame the unknown, how we take something vast and make it small enough to hold in thought. When we name a visitor from the stars, we are saying, in our own gentle human way, that we have noticed it. That in the great sprawl of the universe, this tiny moving light has crossed our attention. It is an act of acknowledgement, not of ownership. For a moment, the anonymous becomes known, and then, just as softly, it slips away again. If you picture 3I Atlas at the moment of its naming, you might imagine it sailing silently through the blackness, completely unaware that somewhere, on a distant blue world, a few curious beings had just given it an identity. The name was written down in databases and shared between observatories, whispered across networks of scientists who spent their nights chasing faint smudges of light. They spoke of it with excitement and caution, running models and simulations to refine its path. Every new measurement confirmed what the first had suggested. It was from beyond. Even the way its name is spoken carries a rhythm that feels right for a traveler. 3I Atlas, a sequence of sound that rolls off the tongue slowly, as though meant to be said under your breath. The I in its middle seems like an accident of notation, but it also feels symbolic. It is the gaze of the sky looking back at us, the connection between the observer and the observed. Through that eye, our small world glimpsed something that had crossed light years to appear before us. All names fade eventually, but the name 3I Atlas will remain in our records long after its faint light is gone. It will exist in the quiet archives of data and in the gentle retellings of those who study the spaces between stars. Perhaps somewhere, if another civilization is also keeping watch, they have their own word for the same small traveler, their own mark in their own language. Maybe they once saw it pass their sun, named it, and let it go, just as we have done. The name we gave it is both ours and not ours. It belongs to the moment of encounter, to that fragile space where curiosity meets the unknown. In the grand silence of the universe, a name is our way of saying hello, even when we know the reply will never come. On a quiet April night in 2020, the sky above Hawaii was clear and still. The telescopes of the Atlas Observatory turned slowly, taking long, patient exposures of the heavens. They were not searching for beauty, though beauty was everywhere. They were searching for motion, for anything that might wander against the fixed pattern of stars. Each photograph captured thousands of points of light, every one a sun, a galaxy, or a reflection of sunlight off something closer to home. Between those points, a single faint streak appeared, subtle and unassuming. It was so dim that most would have dismissed it as a trick of the camera, a blemish of light that did not belong. But to the computers and to the careful eyes that reviewed those images later, that faint streak meant something. It moved differently from everything else. It was the first whisper of a discovery. Astronomers live for moments like that. They know that most nights bring nothing more than repetition, data, calibration, more data. But sometimes, buried among the ordinary, a pattern appears that breaks the rules. When the Atlas system compared the images taken minutes apart, it found that the faint object had shifted more than it should have. Its path didn't match the motion of an asteroid or a comet we already knew. Its trajectory curved oddly, as though gravity were tugging at it in a way that did not make sense for anything bound to the Sunday. At first, no one dared to say what they suspected. Interstellar objects are rare, so rare that until recently, many astronomers spent their whole careers never expecting to see one. But as the data came in, the numbers began to whisper their truth. This object was moving at a speed that no local rock could achieve on its own. It was too fast to be native. Its path through the solar system was open-ended, not looping but slicing. There was no turning point, no arc that would carry it back again. It was passing through, a traveler from somewhere far beyond. For a while, the world outside knew nothing of it. Discoveries like this take time to confirm. Teams at observatories across the planet pointed their instruments toward the faint coordinates that Atlas had shared. Some caught brief glimpses, others only noise. Slowly the orbit took shape, and with it came certainty. The object's speed, direction, and position all pointed to a truth that made the night seem wider. It was not one of ours. It had come from the stars. The designation 3I 2020 F3 Atlas was officially given, and with it, the object took its place among the most elusive family in astronomy, the interstellar wanderers. The moment of discovery passed quietly, without fireworks or fanfare. The astronomers who found it celebrated in the way scientists do, with careful verification and long hours of work. Yet beneath the professionalism, there was wonder. They had glimpsed something that had crossed unimaginable distances to appear, just for a moment, in our skies. When the first press release went out, it was little more than a paragraph. A new object had been spotted, likely interstellar. But those few words carried with them the echo of something immense. To imagine that night is to picture a few people in a dimly lit control room, faces soft in the glow of screens, whispering to each other while the world slept. Outside, the Pacific air was still, and above it all, that tiny light was gliding through space, indifferent to the excitement it had caused. It had been moving for, perhaps, millions of years before that night, and it would continue moving long after the observatory turned its gaze elsewhere. But for that brief instant, paths had crossed. A traveler from the deep dark had met the curiosity of a small blue planet. The discovery of 3I Atlas reminded everyone watching that the universe is not static. It is full of motion, full of surprises. We like to think of the stars as distant and unchanging, but in truth, everything drifts. Whole systems shed fragments, gravity nudges and scatters, hand-worn. Sometimes, those fragments find us. What the telescope saw that night was more than a rock reflecting sunlight. It was the evidence of connection, proof that even across light years, things reach out and touch. Once its existence was confirmed, observatories across the world followed its trail, each taking turns in the watch. It became a faint streak in dozens of images, a line drawn through the sky's stillness. For a few weeks it was there, its motion precise, its glow fading as it moved farther from the Sunday. Then, as quietly as it had arrived, it slipped from sight again. The story of its discovery ended much as it began, not with noise, but with silence. Somewhere beyond the reach of any telescope, 3I Atlas continues on, passing through the outer darkness of our solar system, bound for the endless gulf beyond. The night it was discovered was only a moment, a blink in its long journey. But for those who looked up that evening, it was a reminder that even the vastest distances can be crossed, and that sometimes, in the stillness of a single night, the universe decides to send a visitor. It is difficult to truly understand what speed means when there is nothing to compare it to. Here on Earth, speed is something you feel. The push of wind against your face, the hum of motion beneath your feet, the sound of things cutting through air. In the deep quiet of space, there is no such feeling, no resistance, no sound. Yet, out there, 3I Atlas was moving faster than anything we could imagine. Around 60 kilometers every second, nearly 200,000 kilometers every hour, racing through the solar system with a momentum that no planet or comet could ever match. Still, in the silence of the void, it would have felt like nothing at all. A gliding calm, a steady drift through a place where motion and stillness are the same thing. Speed in space is a strange concept. There is no wind to feel, no friction to fight. Objects move along invisible lines drawn by gravity, their pace dictated by the stars they pass. For 3I Atlas, that motion was ancient, a continuation of something that began long before our sun existed. It may have once circled another star, part of a young system full of dust and debris. Perhaps a giant planet tugged it too close, and with a flick of gravity, sent it outward forever. Once freed, it joined the interstellar current, gliding through regions of cold so vast that even light takes years to cross them. When it approached our solar system, it was already moving too fast to stop. The sun's gravity reached for it, but the visitor barely slowed. Its path bent, curving gently, as if bowing in acknowledgement before continuing on. The speed that carried it in would carry it out again, unchanged, unstoppable. It came from the stars, past our warmth for a moment, and then slipped back into the endless dark. That speed tells a story of escape. To move so swiftly is to be free of every pull, to belong to nothing but the galaxy itself. If you could have followed alongside it, the view would have been haunting. The sun would swell into sight ahead, no brighter than a distant lantern at first, then growing, then fading again as the object passed its closest point. Around it, the familiar planets would be invisible dots of light, all moving too slowly to matter. There would be no sound of rushing, no tremor of movement. Only the faint glow of sunlight scattering across its surface, glinting and fading as it tumbled. Its motion would not feel like flight, but like the quiet continuation of a story already written long ago. Astronomers calculated its speed with precision, yet the numbers barely capture the feeling of it. 60 kilometers each second is not something the human mind easily grasps. It means that every heartbeat, it traveled farther than a jet could in an entire minute. It crossed the distance from the moon to Earth in a little over an hour. It was motion on a scale that made even light feel slow when compared to the long wait of our lives. And yet, to 3I Atlas, there was no hurry. Time does not move the same way in the deep dark. 1,000,000 years of travel would pass unnoticed. There are no landmarks to measure against, no ticking clock to tell it how long it has been drifting. Its journey was pure motion, smooth and endless. When astronomers first realized how quickly it was moving, they knew there would be no chance to study it up close. The best telescopes could only watch for a few short weeks before it was gone. In that time, it moved millions of kilometers farther from us, its faint light growing dimmer until even the most powerful instruments could no longer see it. The universe often gives us only glimpses of its travelers. By the time we look up and notice them, they are already on their way out. To imagine that speed is to imagine freedom in its purest form. 3I Atlas was not bound to any orbit, not tied to any Sunday. It was a citizen of the galaxy, crossing from one system to another, unseen by almost everyone it passed. That quiet, unstoppable pace makes it a kind of messenger. It carries with it the dust of its birthplace, the memory of a star we will never know. As it speeds away now, it drifts toward nothing in particular, following the same calm momentum that has guided it for ages. There is no finish line waiting ahead, no destination it must reach. Its speed is not about urgency, but about continuity. It is easy to think of speed as something fierce, but in the silence of space it becomes gentle. There are no collisions, no trails of fire, only smooth and infinite motion. 3I Atlas moves not like a bullet, but like a feather caught in a current too vast to see. It reminds us that even the fastest things can be quiet, that the universe does not rush but simply continues. Somewhere, far beyond the reach of our sight, that small visitor is still moving, carrying the calm momentum of 1,000,000 years through a darkness that never ends. No one has ever seen 3I Atlas up close. Even the largest telescopes could only catch the faintest glimmer of its light, a single point moving slowly across the background of stars. Yet, from those tiny flickers of brightness, astronomers learned to read its shape the way a musician reads the pauses between notes. When they measured the way its light grew and faded, they found that the rhythm was uneven. Sometimes it brightened as though reflecting more sunlight, and then it dimmed again. That uneven pulse meant it was turning, perhaps wobbling, perhaps breaking apart. It was not a perfect sphere, not a neat marble gliding through space, but something elongated and irregular, maybe even a cluster of fragments drifting together. When scientists talk about an object's shape from such little information, it sounds almost like guesswork, but every shadow and flicker tells a story. As 3I Atlas tumbled, the sunlight caught different parts of its surface, changing how bright it looked from Earth. Those small changes, barely measurable, revealed that it was far from smooth. It may have been long and thin like a splinter of rock, or perhaps two larger pieces orbiting each other gently, locked together in a slow, endless spin. It might have once been a single solid body that fractured during its long voyage through the cold, splitting into pieces that still travel side by side like companions who cannot let go. If you were somehow able to float near it, the shape would probably surprise you. It would not be sleek or even. Its surface would be rough, ancient, scarred by collisions from the early days of its life. You would see craters upon craters, frozen fractures, jagged ridges where the rock had been torn apart by stress and time. The sunlight would glint along edges of ice or dust, flickering like candlelight in the vast black. Up close, it would seem quiet but alive, constantly spinning, balancing itself in slow motion. There would be no sound, no vibration, just the sensation of a world frozen in its own rhythm, dancing softly through emptiness. That tumbling motion may have begun long ago, perhaps the moment it was ejected from its home system. When a fragment is flung away from a star, it does not simply drift, it spins, twisted by the uneven forces that cast it out. Over the ages, those spins can slow or speed up or fragment a body entirely. The vacuum of space is not truly calm. Even without wind or sound, there is pressure from sunlight, from the faint push of photons striking its surface. Over millions of years, that gentle pressure could have nudged 3I Atlas into a slow tumble, a quiet turning that continued without end. Some scientists compared it to Oumuamua, the first interstellar visitor we discovered. That earlier traveler was also oddly shaped, long and narrow, spinning as it passed by. The light from 3I Atlas suggested a similar story, but one even more fragile. Its brightness fluctuated too rapidly, as though it was coming apart before our eyes. Perhaps as it neared the sun, the faint warmth reached deep into its structure, awakening hidden pockets of ice. When those ices vaporized, even slightly, they could have pushed on the body unevenly, making it wobble harder, pulling at its weak points until it fractured. What had once been one piece might have become several. It is a strange thought that something could wander between stars for so long, only to begin breaking apart when touched by light again. The sun's warmth, gentle compared to the fires of its birth star, may have been enough to remind it that it was still fragile. The images taken as it approached seemed to show small companion fragments, little motes following in its wake. These could be pieces torn free by heat, drifting close behind, as if reluctant to let go. Together, they formed a kind of silent procession through the solar system, a family of fragments crossing our skies only once. There is a quiet sadness in that image, a traveler so old, carrying the dust of another world, coming apart as it moves through ours. But there is also a strange peace in it. Breaking does not mean ending. Those fragments will continue their journey, each one carrying the same memory of where it came from. They will move on into the dark, still reflecting faint sunlight for a while before fading completely from our view. Every wobble, every flicker of light, every broken piece tells us something about how things endure and change. 3I Atlas was not a perfect shape. It was irregular, flawed, perhaps fragile, but in that imperfection lies the truth of all things that wander. It did not need to be whole to continue. It only needed momentum and time. As it tumbled onward, scattering faint dust behind it, it showed us that even in silence, even in distance, motion continues. The shape we imagine for it is not just physical. It is a symbol of endurance, a reminder that the universe keeps spinning its stories even when no one is close enough to see them clearly. The light that reached Earth from 3I Atlas was faint, so faint that most eyes would never have noticed it. Yet inside that soft glow, hidden within the smallest fragments of data, there was color. Not bright color like a planet's sky or a comet's tail, but a quiet hue, the kind that speaks of age. It was reddish, not the red of flame, but of rust, of old stone, of things that have been sitting in the dark for far too long. This subtle shade told astronomers that the surface of 3I Atlas had been touched by something ancient and patient, cosmic radiation. In the emptiness between stars, time behaves differently. There is no wind, no rain, no erosion, like we know it on Earth. What shapes a traveler out there is light itself, or rather, the faintest trickle of it. High-energy particles drift endlessly through the galaxy, born from distant explosions and stellar winds. When they strike the surface of a rock or a comet, they break apart the molecules they meet, rearranging them into darker, more complex compounds. Over millions of years, this process stains everything it touches. Ice turns reddish-brown, dust turns dark. What begins as bright and new becomes coated in the color of age. This is what scientists saw in the color of 3I Atlas, a world that had been drifting in that gentle storm for longer than Earth has existed. The reddish tone hinted that it had been exposed to cosmic rays for perhaps hundreds of millions of years, maybe even billions. The surface had been carved not by collisions or heat, but by the slow and constant whisper of the galaxy itself. Its color was not a scar so much as a record, the visible memory of time passing without interruption. Here on Earth, light gives life. In the deep black between stars, it preserves memory. Every photon that brushed 3I Atlas added a faint touch to its surface, a quiet engraving. The reddish tint we saw was not uniform. It may have varied slightly across its body, with some regions darker than others, depending on what materials lay exposed. Perhaps one side was covered in silicate dust, while another held frozen carbon compounds. Each type of material reacts to radiation in its own way, building thin films of organics called tholins. These tholins are common throughout the outer solar system, on worlds like Pluto and Titan, and they are what give many of them their soft red and orange tones. They are also among the simplest and oldest chemical structures in the galaxy, precursors to the molecules that can one day lead to life. So in a way, 3I Atlas was not just carrying color but chemistry, a palette painted by time and distance. If we could have gathered a small piece of it, it might have crumbled like frozen dust in our hands. Under a microscope, its surface would reveal layers upon layers of carbon-rich material built over ages. These are the same materials that once filled our own solar system before planets formed, before oceans existed, before the sun's light even reached its full strength. Every red particle on 3I Atlas was a fossil of starlight, a remnant of the same processes that shaped our beginnings. It is strange to think that color, something so visual, can exist in a place where there is almost no light to see it. For most of its journey, 3I Atlas drifted through a darkness so complete that the nearest star would have looked like a pinprick. Yet, even there, color endured. The faintest red glow, invisible to eyes but measurable through instruments, told us that beauty can survive even in isolation. The galaxy paints its travelers slowly, one particle at a time, with patience no artist could ever match. When that reddish light reached our telescopes, it had been traveling for millions of years. In that span of time, entire species rose and vanished on our world. The continents shifted, the ice caps came and went, and still, the light kept coming, undisturbed, until one quiet night it brushed the lens of a telescope in Hawaii. In that moment, its journey intersected ours. The color we saw was not just a description of its surface, but a connection across time. The red of 3I Atlas is not loud or fiery. It is the red of endurance, the red of something that has waited in the dark and kept its shape. It reminds us that the universe does not need to shout to tell its stories. Sometimes it only whispers in shades of light. To look at that color is to see not just what the object is, but what it has survived. The radiation, the emptiness, the cold, the distance. It carries all of those things in its hue. And when it finally slipped past the sun, that same color lingered, glowing faintly one last time before it faded from view. In its redness was the quiet truth of its journey, that even the most distant traveler bears the mark of light, and that in the silence of the cosmos, every color is a memory of warmth that once was. By the time 3I Atlas approached the inner solar system, it was already changing. From far away, it looked steady, its light smooth and constant, but as it drew closer, something began to shift. The object that had survived the loneliness of interstellar space for millions of years was starting to come apart. The warmth of the sun, gentle to us, was harsh to something that had known only the cold between stars. As its frozen body turned slowly in that new light, the ices buried within it began to stir, waking from a sleep that had lasted longer than humanity itself. Astronomers first noticed that something was wrong when the brightness of 3I Atlas began to flicker in a way that did not make sense. A comet or asteroid usually brightens as it nears the sun, but the pattern here was uneven and unstable. In some images, the object appeared faint and distant. In others, it seemed to flare and stretch. When the data were compared from night to night, it became clear that what they were seeing was not a single object anymore. The visitor was breaking apart. It may have begun with a single crack. Deep within the structure of 3I Atlas, ice that had been frozen solid for eons started to sublimate, turning directly into gas. The gas pushed at the rock around it, expanding through tiny fractures, widening them little by little until the body could no longer hold itself together. When the first piece came loose, the object did not explode dramatically. It simply separated, drifting alongside its twin in a slow and silent dance. The fragments continued to follow the same path, moving together as though reluctant to part. To the telescopes watching from Earth, the two pieces appeared as faint dots of light close enough to blur into one another. As the days passed, those fragments multiplied. Some broke into still smaller shards, leaving behind trails of dust that shimmered faintly in the sunlight. What had once been one visitor had become a cluster of travelers, a loose collection of fragments all moving through space with the same quiet grace. It looked less like a comet and more like a memory dissolving. The dust it shed formed a thin, pale veil that spread along its orbit, a ghostly reminder of its passing. Even as it broke apart, 3I Atlas continued to tell its story. Every fragment that drifted away carried clues about what it had once been made of. The light that reflected off the debris revealed traces of water, ice, carbon, and simple organic materials, the same ingredients that form comets in our own solar system. This meant that despite its distant origin, it was not so different from the objects that circle our own Sunday. Somewhere in another corner of the galaxy, a young star had once built a system much like ours. From that system, 3I Atlas had been flung away, destined to wander until chance brought it briefly into our sky. The breakup of 3I Atlas was not violent, only inevitable. In space, even destruction can be slow and quiet. The force that tore it apart was the same that had drawn it toward us in the first place: sunlight. The same warmth that allows our planet to live is enough to unmake something so ancient and fragile. But there was beauty in that undoing. The spreading cloud of dust and fragments caught the light like a soft mist, glowing faintly against the dark. If you could have stood somewhere far above the planets and looked back toward the sun, you might have seen it as a silver wisp, a breath of light stretching across the black. When astronomers studied its motion after the breakup, they realized that the pieces would continue on their journey together for a while before drifting apart completely. The larger fragments would follow roughly the same path as the original object, while the smaller grains would be scattered by solar radiation, spreading through space like pollen in the wind. Over time, those grains would thin out until nothing visible remained. But though it faded from our instruments, its story did not truly end. The dust of 3I Atlas would keep traveling, orbiting the galaxy as part of the endless exchange of matter between stars. To watch something fall apart can be sad, but there was something strangely comforting in knowing that even in its disintegration, 3I Atlas continued to move forward. It had carried the memory of another world into ours, and even as it dissolved, it shared a little of itself with us. In every flake of dust and every faint glint of sunlight on its fragments was a record of its long journey. Perhaps that is the fate of all travelers, to leave something behind wherever they pass, even if only light. As it broke into smaller and smaller pieces, the visitor became less of an object and more of an idea, a whisper that once, long ago, something crossed the gulf between stars and brushed against our small world. The sun had unmade it, but not completely. Its fragments would keep moving, carrying forward the same calm momentum, gliding away into the dark where the light of no star will ever reach them again. Its brokenness did not mean its story was over. It only meant that its story had changed shape, like starlight scattering into 1,000 soft reflections before fading quietly into night. When astronomers realized that 3I Atlas was breaking apart, they began to look even more carefully at its light. In the absence of touch, sound, or close-up photographs, light is the only voice that space allows us to hear. It travels across unimaginable distances, carrying information about everything it meets. Even the faintest beam that brushes a telescope lens tells a story, though it takes patience and quiet focus to understand what it's saying. 3I Atlas spoke in flickers and changes so subtle that they could have been mistaken for noise. Yet, within those tiny shifts, lay its confession, the quiet code of its shape, its spin, and its crumbling state. Astronomers call this pattern of changing brightness a light curve. It is a way of listening to an object's rotation without ever seeing it turn. As the sunlight hit different sides of 3I Atlas, the amount of light reflected back to us rose and fell. The curve of that light, when drawn as a line on a graph, wavered like a soft heartbeat. Each rise was a bright surface facing us. Each dip was a shadowed side turning away. To read a light curve is to translate brightness into motion, to convert faint photons into a moving picture drawn in time rather than sight. For 3I Atlas, those light curves were erratic. They rose too quickly, dropped too sharply, and changed in ways that hinted at more than one spinning body. It was as if the object were not rotating evenly but tumbling, unbalanced, turning at strange angles as it drifted through sunlight. Some portions of its surface must have been rough, scattering light in uneven directions. Others could have been coated with darker material that absorbed more than they reflected. Every irregularity left its mark in the data, like a whisper caught between breaths. To measure light in this way requires care and trust. Astronomers collect the same patch of sky again and again, comparing each image pixel by pixel, looking for differences so small they seem invisible at first glance. On clear nights, they gather light for hours, stacking exposures to reduce the noise until only the true signal remains. Then they trace it into a line and try to make sense of what it means. For 3I Atlas, this process was like reading a message written by a hand that trembled slightly. Its light told of rotation, of disintegration, of fragments slowly separating, but it also told of resilience. Even as it broke apart, the remaining pieces kept spinning, each carrying the same rhythm in miniature. The beauty of a light curve lies in its honesty. It does not embellish or exaggerate. It records what happens with perfect neutrality, like a diary that writes itself. When the brightness of 3I Atlas rose for the last time before fading, that final peak marked the moment when the largest fragments still reflected sunlight together. Then, as they drifted farther apart, the light scattered too, spreading thin until it merged with the background of stars. What had once been a distinct signal became a whisper drowned in the endless static of the night sky. But even that fading was a kind of language. It told astronomers where the fragments were going, how fast they were spreading, how fine the dust had become. By studying how the light changed over time, they could estimate the size of the pieces and how quickly they were disintegrating. It is remarkable that from such faint traces, we can reconstruct so much. A handful of numbers, a wavering curve, and suddenly the story of a world emerges, its spin, its shape, its death. Light travels in straight lines, but information follows curves. The path from a distant object to understanding wins through equations and patience, through nights of quiet observation. In that way, 3I Atlas became less a fragment of rock and more a lesson in listening. It showed how something can communicate across unimaginable distance without sound or motion, using only reflected sunlight to tell its story. The light that left its surface took several minutes to reach Earth, but the journey that light represented stretched across millions of years. Every photon carried not just brightness, but time, a message from a past so distant it could only be measured in heartbeats of the galaxy. If you were to stand beneath the night sky and imagine what those flickers looked like before they reached our instruments, you might picture a dim object turning slowly against the backdrop of stars, its fractured sides catching sunlight like a lantern in motion. That light would travel outward in all directions, most of it lost forever, some of it intercepted by the mirrors and lenses of telescopes on a small blue world. The scientists watching from there would record it, analyze it, and translate it into meaning. The light curve of 3I Atlas may one day be forgotten, buried in archives among thousands of others, but for a brief time, it was a voice speaking from across the void, a whisper carried by light alone. Its message was simple and human in its way. I am here, it said, for a moment. I am turning, I am fading, and I am moving on. And for that single moment, we heard it clearly enough to know that even in the great silence of space, there are still stories being told. written not in words but in light that will keep traveling long after we stop looking up to see it. The first thing that told astronomers 3I Atlas was not from here was the shape of its path. Every comet and asteroid in our solar system moves around the Sun in a closed curve. Some are nearly perfect circles, others are long, stretched ellipses that carry them from the inner planets out to the edge of the Oort cloud and back again. But all of them, no matter how distant their travels, remain tethered to the Sunday gravity always wins, pulling them home after each long loop. 3I Atlas, however, followed a path that refused to close. It approached the Sun, curved slightly in respect, and then kept going. It would never return. That path is called hyperbolic, and it is the cosmic signature of a visitor. To follow a hyperbola is to escape forever, to move with just enough speed to overcome the pull of the Sun's gravity and every planet around it. It is the difference between orbit and flight, between belonging and passing through. When astronomers first traced the line of 3I Atlas's motion, they realized instantly that it could not have formed in our solar system. Its trajectory was too steep, too fast, and its incoming direction did not match any of the known regions where comets originate. It was as though it had entered our celestial stage through a side door no one even knew existed. Calculating an orbit is a quiet kind of art. It begins with dots of light plotted against the backdrop of stars, each one a position in space recorded at a precise time. From those dots, mathematicians can determine how an object moves and what forces act upon it. For 3I Atlas, the math told a story that stretched far beyond our Sun's domain. Long before it reached the edge of the solar system, it had been moving freely through the galaxy, unbound to any star. It might have been ejected from its original system millions or even billions of years ago, thrown outward by a collision or the gravitational tug of a giant planet. Since then, it had drifted through the Milky Way's quiet lanes, passing other stars unnoticed, until it happened to brush near ours. Its motion was extraordinary. When it entered the solar system, it was moving at more than 30 kilometers per second relative to the Sun, fast enough to cross the entire width of Earth in less than 4 minutes. No asteroid born here could sustain that speed. Even as it neared the Sun, when gravity tried to slow it down, it still kept much of its momentum. That alone was enough to prove it was interstellar. Only something coming from the vast emptiness between stars could have that kind of energy. There was something poetic about that revelation. For all the complexity of telescopes and data analysis, the realization came down to a simple truth: it would not come back. It would curve once around the Sun and continue outward, returning to the deep quiet from which it came. Its story within our skies would last only a few months. Yet in that short time, it taught us that the space between stars is not empty. It is filled with travelers, each carrying fragments of other worlds, passing from one system to another in the slow exchange that has been happening since the galaxy was young. When scientists projected its future path, they saw that it would leave our solar system heading toward the constellation Lynx. It would fade until no telescope could find it, then glide onward into the darkness. In a few million years, it might cross the outer reaches of another star's domain, perhaps to be noticed again by beings who would wonder where it came from. They might trace its motion and find that it once passed through a system with 8 planets and a pale blue world, just as we traced its past. The quiet symmetry is part of what makes these discoveries so humbling. every visitor we find reminds us that we too live in a place that sends things drifting outward into the galaxy. Somewhere far from here, another civilization might one day see the debris of our own system and read in its motion the same truth we read in 3I Atlas. Its hyperbolic path is more than a line of mathematics. It is the signature of freedom. It shows how gravity binds almost everything, but not quite all. Some things escape. Some things wander. The curve of 3I Atlas's journey was proof that not everything that touches our sun must stay. It came from elsewhere, moved through our sky, and continued on without pause. There is a kind of peace in that, a reminder that not everything needs to end in return. Sometimes the story of a traveler is simply that it passed through, left its faint mark upon our instruments, and went on, carrying with it the quiet truth that our solar system, for all its familiarity, is only one stop in an endless galactic voyage. Before 3I Atlas arrived, there had already been 2 other visitors from beyond the solar system. The first was discovered in 2017 and was named Oumuamua, a word from the Hawaiian language meaning a messenger that arrives first from afar. It appeared suddenly, streaking through the inner solar system and leaving astronomers bewildered. It was long and thin, tumbling as it traveled, with no visible tail or plume of gas. Some thought it might be a fragment of rock. Others imagined it could be an ancient comet that had lost its ice long ago. A few even wondered whether it might be something built, though most knew it was simply a natural traveler shaped by time and chance. Oumuamua passed quickly, slipping out of sight before many telescopes could even focus on it, but it left behind a sense of wonder that lingered in every observatory afterward. Then, in 2019, came 2I Borisov. This one was unmistakably a comet. It had a bright coma of gas and a long, shimmering tail of dust stretching behind it. Unlike Oumuamua, which remained mysterious and solitary, Borisov behaved like something familiar, only larger, faster, and colder. It was discovered by an amateur astronomer in Crimea named Gennady Borisov, who built his own telescope and spent his nights scanning the heavens. When his images showed a fuzzy moving spot with a glowing halo, he knew he had found something extraordinary. Scientists confirmed that its speed and orbit meant it had come from another star, and for the first time, humanity was watching a true interstellar comet in action. The gases it released carried traces of carbon monoxide and water, the same ingredients that fill our own comets, proving that the chemistry of distant stars may not be so different from our own. By the time 3I Atlas arrived, astronomers were ready to recognize the signs. They had learned from Oumuamua how to identify a visitor that moved too fast to belong to our solar system, and from Borisov how to study one before it disappeared. Yet 3I Atlas surprised them anyway. It appeared faint and fragile, almost reluctant to reveal itself. Where Borisov had blazed a visible path across the sky, Atlas shimmered softly, its tail delicate, its light unsteady. Some joked that if the first interstellar visitor had been a messenger and the second a cometary traveler, then this third one was a ghost, arriving in pieces and vanishing before anyone could get too close a look. Despite their differences, all 3 shared something profound. They were fragments of other systems, each one carrying the history of a place we would never see. Their compositions hinted at stars that once had their own families of planets, their own icy reservoirs of comets. Somewhere long ago in those systems' early chaos, a gravitational encounter or collision had cast them out, sending them on endless journeys through the galaxy. They drifted for ages between the stars, through the cold and the dark, until eventually, one by one, they found us. The chances of that happening even once are almost impossibly small, and yet it happened 3 times within a few short years. Some scientists think this means that the galaxy is full of such wanderers, and that space between the stars is not empty at all but gently filled with drifting debris from countless systems. The distances between them are vast, but the sheer number of stars makes it likely that these objects pass through the spaces near suns all the time. We simply lack the eyes sensitive enough to see them. The Atlas discovery reminded astronomers that each visitor is not an isolated miracle, but part of a quiet, steady exchange between worlds. Every solar system, including ours, sheds pieces of itself into the galaxy, and those pieces travel endlessly, slipping from star to star. When you picture that, it is easy to see why the discovery of interstellar visitors feels both humbling and comforting. It suggests that the universe is connected in ways we cannot easily measure. The same materials that formed our oceans and our clouds could be scattered across the galaxy, waiting to form again somewhere new. Perhaps, in the distant past, an object ejected from our own system has already brushed past another sun, seen by someone else who looked up and wondered. 3I Atlas, Oumuamua, and Borisov are 3 small reminders that no world exists in isolation. Each one tells us that the boundaries between systems are not walls but open seas, crossed slowly and silently by the debris of creation. To study them is to glimpse the galaxy's quiet conversation with itself, a dialogue spoken in ice and dust, in gravity and time. Long after these visitors have gone, their memory will remain as proof that even in the vastness of space, we are not alone. We share this galaxy with travelers who do not stay, but in passing, they leave behind something precious, the simple knowledge that everything, everywhere, is connected, and that sometimes the most fleeting visitors carry the most enduring truths. When 3I Atlas began to break apart, it released something more delicate than any of its fragments, a trail of dust. Each grain was small enough to drift in sunlight, tiny enough to be carried along by invisible forces that shaped the space around the Sunday. It was a soft unraveling, not a violent explosion, but a slow exhale from a body that had traveled farther than anything else we had ever studied. As it moved, the dust spread into a thin ribbon that curved gently along its path, glowing faintly as the sunlight touched it. Most telescopes could barely see it, but in those faint streaks of light lay the story of what happens when something ancient finally lets go. Every piece of dust that left the surface of 3I Atlas was older than Earth. These grains had once been part of another world, perhaps a comet or a fragment of rock that orbited a distant star. They had been born in light, frozen in time, and carried across interstellar space until this moment of release. To imagine them is to imagine something smaller than the width of a hair, traveling through the darkness for millions of years, waiting for a brief moment of warmth to set them free. Once they drifted into sunlight, they became something else entirely. They became traces, visible to our eyes, proof that even the smallest things can leave a mark across impossible distances. Dust behaves differently in space than it does on Earth. There is no air to slow it down, no wind to gather it, no ground to settle on. Each particle continues in its own quiet line, influenced only by light and gravity. The sunlight itself pushes on it, not enough to see, but enough to change its path slowly over time. Some of the finer grains would have been carried outward, spread into the vast emptiness between the planets, until they joined the soft haze of cosmic material that surrounds our solar system. Others might linger, following a similar orbit for years before drifting too far for any telescope to trace. If you could have followed that dust, you would have seen something almost like a river made of faint light, twisting and fading as it flowed away from the sunday. There is something comforting in that image. Even as the solid body of 3I Atlas fell apart, it left behind a path of beauty, a quiet signature drawn in sunlight. It was as though it had exhaled, sighing across the solar system before disappearing. Astronomers studied the light scattered by the dust, using it to learn about what the object had been made of. The brightness and color of the reflected sunlight told them that these grains contained silicates and carbon compounds, the same materials that make up comets here at home. Some particles glowed faintly red, evidence of organic material formed in the radiation of interstellar space. Others shone with a paler light, hinting at water ice that had survived deep inside the nucleus before the sun's warmth finally freed it. That combination of rock, ice, and carbon was a familiar recipe, one that exists in the building blocks of planets and in the comets that may have seeded early Earth with the ingredients of life. It is a strange thing to think that those same ingredients drift now through the solar system, detached from any world but still part of the same grand story. Perhaps in 1,000 years, one of those grains will fall through our atmosphere as a faint streak of light, burning away in silence while no one is watching. In that moment, a piece of another star system would vanish into ours, completing a journey that began before humans even existed. The dust of 3I Atlas is no longer bound to any single place. It belongs to the galaxy now. To many, the idea of something breaking apart sounds like loss, but in the case of 3I Atlas, it was transformation. The dust was not an ending, but a scattering, a way of sharing what had been hidden for so long. The traveler had crossed the void intact, but it left pieces of itself behind, and in doing so, it became part of us. Each tiny grain is still out there somewhere, drifting quietly through the sunlight, reflecting just enough brightness to remind us that every fragment carries a story. When we look up at the night sky, we are seeing countless such traces from the past. Dust from comets, from collisions, from long-forgotten worlds, all illuminated by the same star that now warms our planet. The trail of 3I Atlas has already faded, too faint for any telescope to find, but that does not mean it is gone. Its particles are still moving, unseen and unhurried, spreading wider and thinner until they blend into the cosmic dust that fills the spaces between planets and stars. They will continue to drift for ages, carrying with them the memory of a world that once existed elsewhere, proof that even in silence and disintegration, beauty endures. In that faint river of dust lies the truth of all travelers, that even when they fall apart, they continue on, leaving behind something that glows softly in the dark. When 3I Atlas drew nearer to the sun, observers expected to see a grand tail, a bright plume stretching across the sky like the ones carried by comets from our own solar system. Instead, what they saw was almost nothing. A faint, translucent wisp extended behind it, barely visible even through sensitive instruments. It was there, but it seemed fragile, hesitant, as if the traveler had forgotten how to shine. That faint tail told a quiet story about the life this object had led before it found us. It had not been asleep for years or centuries, but for eons, drifting through the frozen darkness between the stars where sunlight never reached. Comets that live within our solar system are constantly renewed, Each time they approach the sun, the heat warms their surfaces, vaporizing their frozen gases and revealing new layers beneath. They exhale streams of water, carbon dioxide, methane, and dust, forming the bright tails that we can see even from Earth. But 3I Atlas had not felt warmth in a very long time. The last time light from any star had touched it, our own planet might not even have existed yet. The deep cold of interstellar space had sealed it completely, turning it into a monument of ice and rock, a piece of ancient history preserved in the dark. When that long silence finally ended and it crossed into the reach of our sun, it began to wake, though only faintly. The ice within it was likely hardened to a degree that even sunlight could not easily break apart. Instead of streaming gases, it released the faintest mist, enough to form a thin veil around it, but not enough to give it the radiant tail of an ordinary comet. The gases that did escape may have carried with them fine particles of dust, each one glinting softly before being scattered away. From a distance, it would have looked like the ghost of a tail, faint and uncertain, fading almost as soon as it appeared. There is something deeply moving about the thought of a comet that tries to awaken after so long. It reminds us of how fragile motion and warmth can be. Imagine a body that has traveled for millions of years through the kind of cold that freezes even the gases we breathe. Then, for a few short weeks, it feels the touch of light again. It stirs, it exhales, and for a moment it remembers what it once was before continuing on into the dark. That momentary shimmer of activity is its last expression, a sigh that speaks of endurance rather than loss. Some astronomers suggested that the faintness of its tail meant 3I Atlas had already lost much of its volatile material long before it reached us. It may have once been an ordinary comet around another star, circling again and again until some gravitational accident cast it out. Over time, as it drifted through the galaxy, the heat of nearby stars and the radiation between them slowly stripped it of its most delicate layers. By the time it entered our system, it was less a comet and more a relic, a solid husk that still remembered light but could no longer hold it. Even so, the tail it left was a reminder of that memory, a trace of what once was. Through telescopes, the thin stream of material looked almost transparent. It did not glow with the dense whiteness of other comets, but instead appeared soft, bluish, almost intangible. The sunlight that scattered off its dust had to travel through billions of tiny particles, each one reflecting just a fraction of what it received. That faint reflection was enough to reveal the trail, like a brushstroke of light painted across a dark canvas. For a few brief days, the trail brightened slightly as the comet drew closer to the sun, then faded again as it passed its closest point and began to retreat. It was a short performance, easily missed, yet deeply meaningful to those who watched it unfold. The fragility of that tail is what made it beautiful. It was not a display of power but of grace. It did not roar across the sky or leave a mark that could be seen with the naked eye. It came quietly, glowed softly, and disappeared. In doing so, it mirrored the way most things in the universe exist. Stars flare and fade, planets form and erode, and travelers like 3I Atlas pass through, leaving behind only traces of their light. By the time the comet's remnants moved beyond our reach, the faint tail had completely dissolved. The particles that made it were scattered along its path, too thin to reflect much light, too far apart to be seen again. But they were still there, still moving, still illuminated by the same sunlight that had awakened them. the faint tail of 3I Atlas was never meant to last. It was a temporary bridge between darkness and warmth, between stillness and motion. It was proof that even something that seems lifeless can respond to light, if only for a moment, and that even the smallest shimmer in the blackness of space can remind us how precious that light truly is. When 3I Atlas drew nearer to the sun, observers expected to see a grand tail, a bright plume stretching across the sky like the ones carried by comets from our own solar system. Instead, what they saw was almost nothing. A faint, translucent wisp extended behind it, barely visible even through sensitive instruments. It was there, but it seemed fragile, hesitant, as if the traveler had forgotten how to shine. That faint tail told a quiet story about the life this object had led before it found us. It had not been asleep for years or centuries, but for eons, drifting through the frozen darkness between the stars where sunlight never reached. Comets that live within our solar system are constantly renewed. Each time they approach the sun, the heat warms their surfaces, vaporizing their frozen gases and revealing new layers beneath. They exhale streams of water, carbon dioxide, methane, and dust, forming the bright tails that we can see even from Earth. But 3I Atlas had not felt warmth in a very long time. The last time light from any star had touched it, our own planet might not even have existed yet. The deep cold of interstellar space had sealed it completely, turning it into a monument of ice and rock, a piece of ancient history preserved in the dark. When that long silence finally ended and it crossed into the reach of our sun, it began to wake, though only faintly. The ice within it was likely hardened to a degree that even sunlight could not easily break apart. Instead of streaming gases, it released the faintest mist, enough to form a thin veil around it, but not enough to give it the radiant tail of an ordinary comet. The gases that did escape may have carried with them fine particles of dust, each one glinting softly before being scattered away. From a distance, it would have looked like the ghost of a tail, faint and uncertain, fading almost as soon as it appeared. There is something deeply moving about the thought of a comet that tries to awaken after so long. It reminds us of how fragile motion and warmth can be. Imagine a body that has traveled for millions of years through the kind of cold that freezes even the gases we breathe. Then, for a few short weeks, it feels the touch of light again. It stirs, it exhales, and for a moment it remembers what it once was before continuing on into the dark. That momentary shimmer of activity is its last expression, a sigh that speaks of endurance rather than loss. Some astronomers suggested that the faintness of its tail meant 3I Atlas had already lost much of its volatile material long before it reached us. It may have once been an ordinary comet around another star, circling again and again until some gravitational accident cast it out. Over time, as it drifted through the galaxy, the heat of nearby stars and the radiation between them slowly stripped it of its most delicate layers. By the time it entered our system, it was less a comet and more a relic, a solid husk that still remembered light but could no longer hold it. Even so, the tail it left was a reminder of that memory, a trace of what once was. Through telescopes, the thin stream of material looked almost transparent. It did not glow with the dense whiteness of other comets, but instead appeared soft, bluish, almost intangible. The sunlight that scattered off its dust had to travel through billions of tiny particles, each one reflecting just a fraction of what it received. That faint reflection was enough to reveal the trail, like a brushstroke of light painted across a dark canvas. For a few brief days, the trail brightened slightly as the comet drew closer to the sun, then faded again as it passed its closest point and began to retreat. It was a short performance, easily missed, yet deeply meaningful to those who watched it unfold. The fragility of that tale is what made it beautiful. It was not a display of power, but of grace. It did not roar across the sky or leave a mark that could be seen with the naked eye. It came quietly, glowed softly, and disappeared. In doing so, it mirrored the way most things in the universe exist. Stars flare and fade, planets form and erode, and travelers like 3I Atlas pass through, leaving behind only traces of their light. By the time the comet's remnants moved beyond our reach, the faint tail had completely dissolved. The particles that made it were scattered along its path, too thin to reflect much light, too far apart to be seen again. But they were still there, still moving, still illuminated by the same sunlight that had awakened them. The faint tail of 3I Atlas was never meant to last. It was a temporary bridge between darkness and warmth, between stillness and motion. It was proof that even something that seems lifeless can respond to light, if only for a moment, and that even the smallest shimmer in the blackness of space can remind us how precious that light truly is. When astronomers traced the path of 3I Atlas across the sky, they began to notice that it moved in a way that didn't quite fit the familiar patterns of comets or asteroids born within our solar system. It followed a long, open curve, bending only slightly as it passed near the sun before continuing outward again. That curve, when plotted on a map, was not a loop like the graceful orbits of planets. It was an arc, a single sentence written across the solar system that began somewhere beyond our sight and would end far beyond our reach. Every observation added another word to that sentence until the message became clear. This was not one of ours. The motion of 3I Atlas was precise and silent. It moved according to the oldest laws of nature, the same ones that govern every grain of dust and every star. When something travels fast enough, gravity can bend its path but never capture it. The sun's pull changed its direction just slightly, tilting its course as though the visitor had paused to glance over its shoulder before gliding away. Once that happened, it was clear to everyone studying it that this would be a one-time meeting. It would never return. By calculating its trajectory backward, astronomers tried to guess where it had come from. They followed its line through the sky, tracing it past the outer planets, beyond Neptune's orbit, through the Kuiper belt, and into the vast region beyond where the sun's influence begins to fade. They extended that path farther still, running models of the galaxy's rotation and the gravitational pull of nearby stars. Yet even after all that, the trail did not lead to any single point. It aimed toward a broad region between constellations, a place in the sky without a known source. That uncertainty was part of its beauty. It was as if the object had emerged from the night itself, crossing into our vision from a direction that held only mystery. Some scientists suggested that its origin might lie near a star that once passed close to our solar system millions of years ago. Others thought it could have come from one of the dense regions of the Milky Way, where stars are born in clusters and then drift apart. In truth, the galaxy is filled with stars that constantly move, pulling and scattering fragments of their own systems as they go. Over time, those fragments become wanderers, slipping from one gravitational field to another like travelers changing trains in a cosmic station. 3I Atlas may have been one of those fragments, set adrift by chance and carried here by the quiet flow of the galaxy's rotation. The thought of tracing its origin is as humbling as it is impossible. The galaxy is ancient and alive with motion. To follow the path of one small traveler through that ocean of stars is like trying to trace a single drop of rain back to the cloud that released it. The currents of time and gravity blur every line, and even the most precise calculations can only narrow the possibilities. Perhaps it came from a small red star that once burned brightly and has since faded. Perhaps it came from a system that no longer exists, its planets scattered and gone. Its exact birthplace will never be known, and maybe that uncertainty is fitting for something that traveled so far in silence. When astronomers looked forward, projecting its path into the future, they saw that it would soon be gone from sight. Its arc through the solar system was only a brief detour in a journey that would continue for millions of years. It would climb back out of the sun's gravitational field, gaining distance until even the largest telescopes could no longer detect its faint reflection. After that, it would continue into the endless expanse between stars once again. Perhaps one day, long after we are gone, it will cross another system, and someone else will notice the same faint streak of light and wonder who once saw it before. There is something deeply poetic about an orbit that cannot close. Most things in the universe move in cycles, repeating paths and predictable rhythms. But a hyperbolic orbit is different. It is a motion that belongs to the in-between, neither captured nor fully free, only passing through. 3I Atlas followed that curve perfectly, a traveler who never lingered, carrying no destination but forward. The mathematics of its motion are exact, but the meaning we find in that motion is softer. It reminds us that not everything must return to be real. Some stories exist only as crossings, brief and luminous, leaving behind nothing but curiosity and a line through the stars that says, for a moment, something passed this way. There is a quiet idea that objects like 3I Atlas do not always travel alone. The universe has a habit of creating things in company. Stars form in clusters, planets gather from shared disks of dust, and even comets and asteroids are sometimes born as twins. When astronomers studied the strange, uneven brightness of 3I Atlas, some wondered if it might not be a single piece but a pair, two fragments bound by gravity, circling one another as they drifted together through the void. Others went further and imagined that somewhere, still beyond the reach of our instruments, there might be other pieces of the same family traveling along slightly different paths through the galaxy, fragments of one ancient world scattered among the stars. The possibility that 3I Atlas had companions is more than just romantic speculation. The universe is full of evidence that fragmentation is common. When large bodies are tugged by gravity or struck by collisions, they split apart, sending shards in every direction. Some of these fragments remain loosely bound, moving together like dancers, keeping time to the same silent rhythm. Others are flung away completely, destined to wander forever. If 3I Atlas was indeed a remnant of a shattered body, then somewhere out in the darkness there may still be other fragments from that same event, perhaps dozens or hundreds, each one tracing its own endless arc through the galaxy. We will likely never see them, but the thought that they are out there gives a kind of continuity to its story. It did not travel from a single place. It traveled from a shared past, If those siblings exist, they would be difficult to find. The distances between stars are vast, and the time since their separation could be counted in billions of years. Even if they began close together, each gravitational encounter along the way would have nudged them onto new paths, stretching their once shared orbit into a web of lonely trajectories. But in the grand scale of the galaxy, the idea that some of them might still drift within the same general region is not impossible. They could be so faint that no telescope could ever pick them out from the background of starlight. Yet in a way, that invisibility suits them. It keeps their connection quiet, hidden within the dark where their journey began. To think of these companions is to imagine a kind of family dispersed by time. Each fragment carries the same ancient material, the same chemistry that once belonged to a single parent body. Perhaps that body was a comet orbiting a distant sun, or maybe it was part of a forming planet that never reached completion. A collision or a gravitational pull might have shattered it, sending its pieces outward. Some might have fallen back, melting and reforming into new worlds. Others, like 3I Atlas, were given enough energy to escape entirely, cast into the galactic sea. Each one became a traveler, but all of them still carried the signature of their shared origin, written in their mineral and molecular patterns. If 3I Atlas has siblings, it is comforting to imagine them as small glimmers scattered through the night, unseen but moving in quiet unison. Their separation would not mean loss but endurance. In the emptiness between stars, connection takes on new meanings. There is no touch or sight to hold on to, only motion, only the certainty that each one continues. The universe is full of things that remain bound without contact. Gravitational forces stretch across light years, linking objects that will never meet again. In that sense, the possible companions of 3I Atlas are still with it, still bound by the memory of their creation, following paths that forever echo one another. Astronomers sometimes talk about these relationships in the language of probability and dynamics, but there is also a softer truth beneath the numbers. The universe, for all its coldness, does not often create in isolation. It tends to build in clusters, in families, in groups that form together and then drift apart. Even as those groups scatter, their origins tie them together. 3I Atlas, solitary as it seemed to us, may be part of something larger than we can imagine, a hidden constellation of fragments all born from the same moment of cosmic upheaval. Each one carries a piece of the original story, and through them, that story continues across distances we cannot measure. If we could see them all at once, perhaps from a perspective high above the galaxy, they might appear as faint points of light moving slowly in the same general direction, their paths bending and curving like threads woven into a vast tapestry. Each one glows briefly when it nears a star, then fades again as it returns to darkness. 3I Atlas was the one that happened to cross our light, the one we could glimpse for an instant before it went on. The others, if they exist, will pass through other skies, seen by other eyes, each one carrying a fraction of the same quiet story. That even in the vast emptiness between suns, nothing is ever truly alone. Every grain of dust released by 3I Atlas was a message from another star. The material that made up this small, fragile traveler had not been formed in our solar system but somewhere far beyond it, in a world that once circled a different Sunday. When astronomers studied the faint light reflected from the object before it vanished, They realized that even a single particle shed from its surface could hold an entire history. The composition of that dust was not random. It was the record of a distant origin written in minerals and frozen gases. To touch it would have been to touch the outskirts of another world, the residue of another dawn. If we had been able to capture a fragment of 3I Atlas and bring it home, it would have offered something extraordinary, a sample of alien stardust. That dust could tell us how its parent system was born, what its star was made of, and how the chemistry of distant places compares to our own. The elements that make planets are universal, but the patterns they follow vary. Some stars form with a little more carbon, others with more oxygen or iron, and these small differences shape the kinds of worlds that can form around them. The dust of 3I Atlas carried those differences inside it, quietly preserving them across millions of years of travel. The dust itself would have been impossibly small. Most grains were likely no wider than a strand of smoke, each one a tiny shard of rock or ice mixed with the faint traces of organic compounds that form when radiation acts on frozen gases. Many of these molecules are fragile, but the cold of space kept them intact. While it drifted between stars, no heat disturbed them, no atmosphere or current reshaped them. Each grain was a miniature museum of cosmic chemistry, containing within it a story that began before our own solar system had even formed. Scientists dream of one day capturing material like this, of building spacecraft that can sweep through the tails of interstellar visitors and gather their dust for study. Within those particles could lie answers to some of the oldest questions about life and formation. The same ingredients that built 3I Atlas might have also seeded young planets elsewhere. It is possible that the basic materials for life, carbon, nitrogen, and complex organics, do not belong to any one system at all. They travel freely, scattered by collisions and comets, drifting between stars until they find a new home. In this way, 3I Atlas was not only a traveler but a messenger, carrying pieces of its original world into new realms, a courier in the endless exchange of matter that unites the galaxy. The idea that dust from another sun could fall across our own is quietly humbling. A few particles released during the comet's disintegration may still wander within the solar system even now. They are too small to detect, drifting unseen between the orbits of planets, illuminated only when struck by sunlight at just the right angle. Eventually, some will escape again, carried outward by the faint push of light pressure, and return to the interstellar sea. Others may linger, spiraling slowly toward the sun, or colliding with other dust to become something new. The boundaries between systems are more porous than we once believed. Nothing stays in isolation for long. If we could hold one of those grains, we would be holding time itself. It would contain atoms forged in the heart of its parent star, atoms that were once part of a living sun, now perhaps long extinguished. They would have been expelled into space when that star grew old, swept into clouds that later condensed into planets and comets. From there, one fragment broke free, traveling across the gulf until it entered our sky as 3I Atlas. Inside that single grain of dust would be the evidence of countless cycles of creation and destruction, proof that everything in the universe is part of an ongoing exchange. When we look up at the night sky, we see stars as distant points of light, separate and solitary. But the dust of 3I Atlas reminds us that the galaxy is not divided into neat territories. It is a web of movement, of materials constantly trading places. A grain formed near one star can travel through the domain of another, carrying within it the seeds of new beginnings. The same atoms that once belonged to 3I Atlas might one day find themselves in the soil of an alien planet or the clouds of a newborn system. To think of it this way is to see the universe as a kind of grand breathing, inhaling and exhaling across eons. Stars give birth to matter, and that matter drifts until it becomes part of something new. Every fragment of 3I Atlas was part of that rhythm. The dust it left behind continues to move, quiet and invisible, crossing the spaces between worlds. And somewhere in that drifting haze, the same atoms that once formed a distant comet are still journeying, still whispering across light years that nothing in the cosmos ever truly ends. When the telescopes turned toward 3I Atlas, astronomers listened for more than light. They searched for any signal, any whisper across the invisible waves that fill the universe. They checked the radio spectrum, scanning for transmissions or pulses that might suggest something other than nature's slow work. There was nothing. No hum, no rhythm, no pattern, only silence. The kind of silence that feels complete, like an untouched canvas. To some, that quiet was the most beautiful part of all. It was proof that the universe does not need to speak loudly to be interesting. Sometimes, it simply drifts unbothered and self-contained. The absence of radio signals told astronomers that 3I Atlas was ordinary in the most extraordinary way. Its silence meant that it was not metallic or hollow or filled with anything that could echo a signal. It was not a machine. It was a piece of rock and ice, natural, ancient, shaped by forces so slow and subtle that they feel timeless. It carried the indifference of the cosmos, the steady patience of things that exist without needing to be known. When scientists measured its light, they found no strange flickers, no artificial glints, just the steady reflection of sunlight across a fractured surface. It was a small comfort, perhaps, to find that even in an age when speculation can run wild, the universe still offers mysteries that are purely natural. The instruments that watched it recorded everything they could. They measured its brightness across different wavelengths, comparing infrared and visible light, hoping to learn how its surface absorbed and released heat. The results came back plain and familiar. It behaved like an icy body, one covered in dark, carbon-rich material, and perhaps a thin layer of dust. Its temperature rose slightly as it approached the sun, and then fell again as it moved away. Nothing about it seemed deliberate or designed. It was quiet in every measurable way. For some, that quiet sparked reflection rather than disappointment. The discovery of 3I Atlas had briefly stirred the imagination of people who hoped for signs of other civilizations, for evidence that the galaxy might be filled with minds as curious as ours. But the silence was not a rejection. It was simply the universe being itself. Not every visitor has to carry a message. Some arrive only to remind us that nature's work is enough. The rocks, the dust, the slow arcs through space, all of them are beautiful in their simplicity. There is a certain peace in knowing that 3I Atlas was just a rock from another Sunday. It meant that the processes that shape our own solar system are not unique. Everywhere in the galaxy, worlds form and fracture, comets spin into being, and fragments are cast out to wander the stars. The silence of 3I Atlas spoke of that shared pattern. It was the quiet of belonging to something vast and ongoing. The same physical laws that formed our planets had formed it too, and those same laws carried it here. To think of that silence is to imagine a kind of conversation without words. The universe does not shout its secrets. It does not need to. It speaks in gravity, in light, in the soft scatter of particles across endless space. We listen through telescopes and instruments, translating what little we can into language, but what it says is always the same, that we are part of something continuous and boundless. 3. Atlas was not an alien artifact, not a message written in code. It was a reminder that the ordinary is miraculous when seen from far enough away. Even after it had faded from view, scientists continued to monitor the space it had crossed, hoping for lingering signals or traces of unusual radiation. None appeared. The traveler had moved on, leaving behind only the echo of data and the memory of its passing. The silence remained, but it no longer felt empty. It felt full, like the pause between two notes in a song that continues beyond hearing. That is the kind of quiet the cosmos gives us, a quiet that invites reflection rather than fear. If anything, 3i Atlas deepened our sense of wonder. Its quietness was not the absence of meaning, but the presence of calm. In that stillness was the reassurance that the galaxy does not revolve around noise or drama. It is built on patience. Stars burn, planets spin, comets wander, and all of it happens with a grace that does not need to be announced. The silence of 3i Atlas was the silence of the universe itself, vast and unhurried, content to exist without explanation. When we think of that silence now, we might imagine it not as emptiness, but as rest. The kind of rest that follows movement, the pause between one journey and the next. 3i Atlas carried that rest with it, and in watching it pass, we caught a glimpse of how quiet the universe truly is. In that quiet, there is meaning enough. As the weeks passed, the light from 3i Atlas began to weaken. It was not sudden, not a vanishing, but a gradual fading, like the dimming of a candle that has burned through most of its wax. Each night the telescopes captured its image. The glow grew fainter, its outline less distinct. The fragments that had once drifted together began to spread apart, carried on their individual trajectories, each following its own quiet curve through the solar system. What had once been a single presence was now a memory, dissolving into the background of stars. The fading of 3i Atlas was expected, yet it carried a quiet sadness with it. For a few short months, it had given us something to follow, a visitor to study, a story to tell about the vastness of the cosmos. But the universe does not linger for our convenience. It moves at its own pace, slow and constant, without sentiment. The faint light that had seemed so miraculous when first discovered was only the reflection of sunlight on dust and ice. When that dust scattered, there was nothing left to catch the light. The traveler returned to darkness, as if it had only paused briefly to remind us that it was real. Astronomers continued to track its fading path as long as they could. Observations from different observatories across the world confirmed that the fragments were dispersing more rapidly than anyone had anticipated. The largest pieces were still visible through sensitive instruments, but the smaller ones had already slipped beyond detection. The sunlight that had revealed its presence now betrayed its departure, scattering across too wide an area to be measured. The curve of its orbit still existed in their calculations, a line plotted on screens and in equations, but the object itself had become a ghost. The disappearance of something so small might seem inconsequential, yet there was a certain gravity in watching it go. In its short visit, 3I Atlas had bridged the impossible distances between stars. It had traveled farther than anything humanity had ever built, carrying with it a history that stretched back to the beginnings of another system. And now, that story was fading from sight. It was easy to forget that such things happen all the time. Objects from beyond our solar system likely pass through our space regularly, unseen, unnoticed, their faint reflections too dim to register even on the most powerful sensors. 3I Atlas was one of the rare few that we caught, a fleeting glimpse of the ongoing exchange between stars. In its fading, there was a lesson about perception. The universe is not static. It is a collection of moments that come and go, each one visible only for a short time. To watch something disappear is to be reminded that all light is temporary, that visibility itself is a brief condition. The glow of a comet, the fire of a star, even the brightness of our sun will one day fade into the same quiet obscurity. The cosmos is an artist who works in eras, painting with light that eventually dims to shadow. Somewhere beyond the orbit of Jupiter, the last visible fragments of 3I Atlas continued their slow journey outward. They would keep traveling, too small to reflect much light, too scattered to be noticed again. Their momentum would carry them beyond the outer planets, past the edge of the heliosphere, and back into interstellar space. In time, even the faint trail of dust would disperse completely, blending into the great invisible ocean of material that fills the galaxy. It would be as though the visitor had never been here at all, except for the records kept by those who saw it. But even as its light disappeared, its story remained. The data gathered from its brief presence would live on in research papers, in digital archives, and in the memories of those who spent sleepless nights following its movement. It became part of our understanding of the galaxy, a small addition to the map of all that drifts between stars. Every time a new object is found, astronomers will think of it again, comparing its path, its speed, its color, to the faint traces 3I Atlas left behind. Its fading light became a kind of guide, reminding us what to look for when the next traveler comes. When something leaves our sight, it is easy to call it gone, but in the language of the cosmos, disappearance is just another form of continuation. The fragments of 3I Atlas are still out there, moving through the quiet, carrying with them a little of our sunlight, a memory of our brief meeting. They will not stop. They will drift beyond the reach of our instruments, beyond the reach of our imagination, but they will keep existing in the same slow rhythm that governs everything. To fade is not to vanish. It is simply to move beyond what our eyes can hold. The traveler's light may have dimmed, but its journey continues, unhurried and endless, beneath the same stars that once revealed it to us. Even though 3I Atlas was only visible for a short time, its visit left behind questions that lingered long after its light had faded. It taught astronomers that absence can be as revealing as presence, that even what is no longer seen can tell a story. By studying its brief passage through our skies, scientists learned not just about one fragment of rock and ice, but about the hidden structure of the galaxy itself. What we saw in 3I Atlas was more than a visitor. It was a clue, a hint that our solar system is not sealed off, but open, part of a much larger exchange that has been taking place since the beginning of time. Every interstellar object carries with it a quiet kind of truth. 3I Atlas showed us that the space between stars is not a boundary but a bridge. For centuries, humanity imagined the solar system as an island, a self-contained home surrounded by emptiness. But the discovery of wanderers like this one changed that view forever. It revealed that the galaxy is constantly in motion, a grand circulation of debris, dust, and ancient fragments that move freely from one star to another. Each time a comet or asteroid is ejected from a system, it becomes part of this migration, joining the endless stream of travelers that weave through interstellar space. 3I Atlas was one of these wanderers, and by crossing our path, it reminded us that we are connected to everything else around us in ways we are only beginning to understand. Its faint reflection confirmed something profound, that interstellar visitors are not rare. They are everywhere, but most are invisible, too dim for our instruments to detect. 3. Atlas was simply one of the few that happened to be caught in the narrow beam of our awareness. It showed us that the universe is full of travelers just like it, each one carrying the chemistry and the history of the stars that gave them birth. Together, they form an unseen network that stretches across the Milky Way, linking systems that will never meet directly. The space between the stars is not quiet. It is alive with motion, even if most of it escapes our sight. Through this small visitor, we also learned more about ourselves. The study of interstellar objects is as much about our own curiosity as it is about the objects themselves. Each discovery expands the boundary of what we know, but also deepens our sense of humility. 3I Atlas arrived unannounced, passed briefly through the light of our sun, and then left again without hesitation. It did not slow down, it did not change its path, and it did not respond to the fact that we were watching. It was unaware that it had been seen at all. In its quiet motion was a reflection of the universe's calm indifference to our awareness of it. Yet in that indifference lies a strange comfort. The cosmos continues, steady and beautiful, whether we are here to notice or not. From its fading trail of dust, astronomers pieced together models of how often such visitors might appear. The conclusion was surprising. There are likely thousands of interstellar objects passing through our solar system at any given time, each too faint for us to see. Some may be no larger than pebbles, others the size of mountains, each carrying with it the story of a world we will never know. Most will pass unnoticed, but a few will cross paths with our telescopes again. In that sense, 3I Atlas was not an anomaly. It was part of a pattern, one thread in a vast tapestry of motion that stretches across the stars. The realization that we are constantly visited by such travelers changes how we think about the universe. It means that our solar system is not isolated, but part of a great exchange of matter that may have been happening since the galaxy first formed. The water in our oceans, the carbon in our cells, even the metals in the soil may once have come from other stars, delivered by ancient comets like 3I Atlas, long before the Earth was born. And the same will happen again. Our system too will send fragments outward, small ambassadors that will one day pass through other skies, unnoticed by other beings who look up and wonder. In the end, what 3I Atlas taught us was simple and vast all at once. It reminded us that movement is the natural state of the universe. Nothing stays still. Stars are born, drift, and die, and in between, their remnants wander, carrying memories from one place to another. We live within that flow, both observers and participants. The light that touched 3I Atlas before it faded is the same light that now touches us, the same that will touch the next traveler when it comes. What we learned from nothing, from the empty silence it left behind, was everything we needed to know. The universe is connected, it is shared. And every visitor, no matter how brief, is a reminder that even across the greatest distances, everything belongs to the same story. When scientists tried to describe how 3I Atlas had come to visit us, many turned to a simple metaphor, a game of cosmic pinball. Every star in the galaxy exerts a pull, a gentle gravity that shapes the movement of everything nearby. Around each one, planets form, comets swirl, and countless small fragments drift. Sometimes, these fragments are caught in delicate orbits, circling their home stars for billions of years. Other times, a collision or a passing giant planet gives one a little more speed, just enough to break free. Once that happens, it begins to wander, moving through the galaxy as if it had been nudged from one side of a vast table to another. 3I Atlas was one of those pieces, a marble that had rolled away from its home and found its way to ours. The galaxy itself is like a great network of these gravitational interactions, a quiet storm of motion where stars, planets, and debris constantly trade momentum. Every encounter, every passing star, every close approach shifts something. A system that looks calm and stable is always moving beneath the surface. Over time, even the tiniest changes can fling an object far beyond its original orbit. 3I Atlas was a child of that process, a small outcome of immense forces. It had likely been ejected from its home long ago, perhaps by the gravity of a massive planet or a nearby star that passed too close. Once free, it drifted outward, still holding the same speed it had been given at birth, carrying it from one corner of the galaxy to another. To imagine that journey is to imagine a vast, slow dance without music. The fragment would have drifted for millions of years, crossing the spaces between star systems where distances lose their meaning. It might have passed near the faint glow of other suns, each one tugging gently, bending its path by a fraction before letting it go again. Over time, its trajectory would have become smoother, straighter, until it was no longer tied to any particular star. It belonged to the galaxy itself, a free traveler moving through its wide, spiral arms. When it entered our solar system, it was not seeking anything. It simply followed the line that physics had written for it. The sun's gravity reached out to it like a soft hand, bending its path once more, guiding it through the plane of our planets before sending it back out again. For a brief time, we were part of its route, one more gentle deflection in a journey that had begun before life existed on Earth. That motion, when seen from afar, would look almost like the slow ripple of a current, one object passing from the influence of one gravity well to another, each encounter shaping the next. Astronomers sometimes think of this process as a kind of galactic conversation. Each star sends out fragments, and some of those fragments find their way into the gravitational fields of others. Matter moves from one place to another, carrying stories of its origin in the elements it contains. 3I Atlas may have begun in a system rich in carbon or iron or volatile ices, and those characteristics still lingered in its makeup when it reached us. Its chemistry was a message, an unintentional one, but a message nonetheless, showing that what happens in one system does not stay contained within it. Every ejection, every wandering object adds to the shared fabric of the Milky Way. To picture this exchange is to see the galaxy not as a cold void, but as a living network, a place of endless motion and contact. Stars are born in clusters, drift apart, and leave trails of debris that cross paths again millions of years later. 3I Atlas was a reminder that nothing in this great structure stands alone. It was not just a rock passing through our sky, but part of an unbroken cycle of scattering and gathering that keeps the galaxy alive. It brought with it the memory of the forces that made it, the invisible fingerprints of another system's storms. If we could somehow see all the trajectories of all the wandering fragments in the Milky Way at once, the view would be dazzling. There would be billions of threads, twisting and looping around stars, intersecting and diverging like the pattern of waves across a great ocean. 3I Atlas would be one of those threads, faint but steady, a single line that touched our sun's light for a moment before curving outward again. Its presence in that vast pattern was brief, but it mattered. Each small deflection, each fragment that changes direction, shapes the larger balance of the galaxy in ways too subtle to measure, but too persistent to ignore. In the end, the motion of 3I Atlas was not chaos. It was harmony, the kind that only gravity can compose. It moved as everything else does, not randomly, but according to a rhythm older than stars. Its passing through our solar system was one note in a melody that has been playing for billions of years, a melody of motion, connection, and quiet persistence. And as it left, continuing its long glide into the dark, it carried with it the echo of that song, the same one that hums beneath every orbit and every drifting world in the endless, gentle game of the galaxy. There is something profoundly human about the way we think of loneliness. Yet in the cosmos, solitude takes on an entirely different meaning. To drift alone through the space between stars is not a tragedy, but a kind of existence all its own. 3I Atlas embodied that truth. It had no home to return to, no orbit that would bring it back around to familiar ground. It moved endlessly forward, carrying the quiet dignity of something that belongs to no one. To some, that might seem like a sad fate, but in a universe where everything is always in motion, perhaps there is beauty in the act of wandering. As it traveled, 3I Atlas experienced time in a way we cannot. Human lives are measured in years, and our sense of duration is tied to the cycles of Earth. The journey of a traveler like this, though, is measured in epochs. Millions of years can pass without change. The stars that once glowed behind it fade from view, replaced by new constellations ahead. Entire civilizations could rise and disappear in the span of one of its crossings, and it would glide onward, indifferent and constant. Its speed was immense, yet in the scale of its voyage, that speed meant patience. It would spend millennia passing from one region of the galaxy to another, wrapped in silence and cold, untouched by anything but gravity and light. To travel without destination is to live without expectation. 3I Atlas did not move with intent. It had no purpose, no place to rest. It simply continued because there was nothing else to do. There is something quietly comforting in that inevitability. It shows us that motion itself can be meaning. The universe does not require reasons to keep going, it simply does. Every particle, every wave of light, every drifting comet moves because the laws of nature give it no alternative. That rhythm, steady and unbroken, is what makes the cosmos eternal. 3I Atlas was part of that rhythm. Its endless travel was not a sentence but a song, a verse that joined countless others in the great music of movement. When we imagine its journey, we can almost picture it gliding through starlight so faint it would barely illuminate its surface. Around it, the galaxy would unfold like a vast, dark plain sprinkled with distant fires. Occasionally, it might cross a faint nebula or pass through a region where interstellar dust thickened the darkness into mist. Every few million years, it might come close enough to another star to feel the faint tug of gravity, a reminder that even in the emptiest parts of space, there are connections that cannot be broken. But those encounters would be brief. After each one, it would continue onward, solitary again, its course unchanging. There is a melancholy to this idea, but also a lesson. On Earth, we are bound by the pull of gravity, by the cycle of day and night, by the shortness of our own time. We think of isolation as loss because we depend on nearness to give our lives meaning. Yet, in the scale of the galaxy, isolation is not an absence, but a form of being. Everything drifts, and in drifting, everything participates in the same vast stillness. 3. Atlas did not suffer its solitude, it defined it. It was a traveler not lost but free, belonging everywhere and nowhere at once. Perhaps what makes it beautiful is that it reminds us of our own impermanence. We too are travelers, though our paths are shorter and our distances smaller. The Earth moves around the Sun moves around the center of the galaxy, and in time, everything we know will drift elsewhere. The loneliness of 3I Atlas is not so different from our own, except that it stretches beyond comprehension, yet in that stretch lies wonder. And from its existence is proof that the universe allows for movement without destination, for endurance without arrival. It glides forward, unchanged and unbothered, a silent witness to ages we can only imagine. To think of it now, far beyond our sight, is to imagine peace, not the kind of peace that comes from rest, but the peace of motion unbroken. It will continue through the galaxy long after our planet has cooled and the sun has dimmed. It will pass other systems, other worlds, and perhaps, on one of those, someone will look up and catch a faint glimmer of light and wonder, as we once did, about the small, distant traveler crossing their sky. In that moment, its loneliness will become connection again, a brief link in the endless chain of curiosity that binds all beings who look toward the stars. To call 3I Atlas unique would not be entirely true. What made it special was not that it was the only one of its kind, but that it was one of the rare few we noticed. Astronomers have long suspected that our solar system is constantly crossed by interstellar objects, silent travelers passing unnoticed through the spaces between planets. Most are too small or too dark for us to detect. They drift in and out of our celestial neighborhood like shadows, faint and forgettable. 3I Atlas was different only because, for a brief time, its path aligned with our attention. We happened to be looking in the right direction when it appeared, and that coincidence turned it into a story. Statistically, thousands of interstellar fragments move through the solar system every year. Some are the size of pebbles, others as large as mountains. Most do not shine, and even when they reflect sunlight, the brightness is so faint that our instruments cannot separate it from the endless background of stars. A few may burn in our atmosphere, becoming meteors that streak briefly across the sky before vanishing, and we never know that the light we saw came from another Sunday. The discovery of objects like 3I Atlas and those that came before it has shown us that we are surrounded by motion. The space we thought was empty is full of crossings, each one a meeting of paths that may never happen again. For a short time, 3I Atlas became our guest, sharing the same sunlight that warms Earth, the same gravity that shapes our planets. It moved among us, indifferent to the worlds it passed. It did not alter its course, and it made no mark. But in its passing, it connected us to something greater. Its presence confirmed that the Milky Way is a place of exchange, where the debris of one system can drift through another like pollen carried on a galactic wind. They see. That thought alone changes the way we see our own place in the universe. We are not alone in our isolation. Every star, every planet, every fragment of ice or rock belongs to the same vast circulation. There is comfort in knowing that we are constantly visited, even if we rarely notice. These travelers bring no danger and no message, only the quiet proof that creation is not confined to any single region. Each one that crosses our path carries the chemistry of a distant world, the minerals and ices shaped under the light of another star. In them, we see echoes of our own beginnings. Perhaps long ago, similar travelers carried material into our young solar system, seeding it with the building blocks that would one day become oceans and clouds. If that is true, then life itself may be part of the same grand exchange that 3I Atlas represented. When we look at the sky, we imagine distance as separation. Stars appear scattered, each one shining on its own, but the galaxy is not a map of loneliness. It is a web of invisible threads connecting everything to everything else. Gravity binds it, motion stirs it, and time stretches it into a single continuous story. The path of 3I Atlas was one small stroke in that story, a fleeting line of light drawn across the darkness. It passed through our space without noticing us, yet its very existence reminded us that nothing in the universe truly travels alone. Every particle that drifts between stars becomes part of a shared history, adding to the same endless motion that links all things. Even now, more travelers are coming. Some are already within our system, moving unseen, their paths marked only by faint disturbances in light. Others are still far away, sliding silently through the void, their journeys spanning millions of years. We will find more of them in time, and each will tell the same quiet story in its own way. Together they will teach us that the solar system is not a closed circle, but a crossroad, a place where the galaxy occasionally passes through itself. 3I Atlas was one among billions, but for a moment, it became our connection to the infinite. It reminded us that the vastness of space is not emptiness but motion, and that the same forces that flung it from its home also keep us in ours. It passed without fanfare, without noise, and yet it left behind a trace of wonder that lingers. Somewhere out there, thousands more are moving now, unseen, each carrying a memory of another sun, each bound for places we will never go. And as they pass, they make the universe feel just a little smaller, as if every distant world were breathing in rhythm with ours. When people hear the word interstellar, they often imagine something distant and unreachable, a realm beyond the grasp of even imagination, yet the truth is softer and closer. Interstellar simply means between the stars, and the space between them is not a void of separation but a bridge. 3I Atlas reminded us of that when it passed through our solar system. It carried no banner to announce its origin, no proof of purpose, only motion. Yet in that quiet passing was the simple fact that the boundaries between worlds are not walls. They are doorways that the universe keeps open, allowing material, energy, and memory to move freely through its vastness. From the moment 3I Atlas entered our system, it carried with it the light of another place. The sunlight we used to see it was not its first light. For millions of years, it had been warmed, ever so faintly, by other stars, touched by their glow as it moved through their distant fields. Each time it passed near one, it borrowed a little of that light, a small shimmer that it carried forward. When it reached us, the glow we saw was not just sunlight reflected from its surface, but the culmination of countless encounters with the galaxy's starlight. It was a living record of connection. Interstellar is a word that sounds cold, but what it really describes is relationship. The space between stars is where everything meets. It is where the remnants of one system drift into the birthplaces of another, where the dust of dying stars feeds the clouds that will form new suns. The Milky Way is full of this circulation, a steady rhythm of giving and receiving that stretches across unimaginable distances. 3. Atlas was a participant in that rhythm, one small traveler in the endless movement of matter that ties the galaxy together. Astronomers sometimes describe this movement in terms of energy and gravity, but there is also a quiet poetry to it. Every star, every planet, every fragment of rock gives something to the space around it. Nothing remains isolated. The light from our own sun will eventually reach other systems, brushing against their comets and asteroids, leaving the faintest mark. Likewise, the light of other stars reaches us every night, painting our sky with memories of places we will never touch. The passage of 3I Atlas was a more tangible form of that same connection, a reminder that we are not spectators but participants in the same shared cosmos. When we call something interstellar, we are acknowledging that it belongs to more than one home. 3I Atlas was not bound to a single star, and in that sense, it belonged to all of them. It passed through the light of countless worlds, carrying with it traces of chemistry and structure that formed under another sky. It is possible that the ice locked within it held atoms older than our solar system, atoms that once burned in the heart of a vanished Sunday. In that way, it was a messenger of the galaxy's memory, carrying within it the proof that nothing in the universe is ever truly separate. The idea that something can travel between stars and remain unchanged is humbling. It suggests that movement itself is a form of connection, that every object we see in the night sky has, in some way, touched something else. The universe is a conversation conducted in the language of motion. When 3I Atlas brushed through our skies, it added its own voice to that dialogue, a whisper rather than a shout, saying that we are part of a community far larger than we can comprehend. When its light faded and its fragments disappeared beyond the reach of our telescopes, what remained was the awareness that the space between stars is not empty but full of shared possibility. Each interstellar traveler is a reminder that the universe is not defined by its distances, but by its connections. We live beneath a sky that never stops exchanging its contents, a sky where light, dust, and gravity weave together the stories of distant places. 3I Atlas was a small part of that tapestry, a thread that crossed briefly through our own. And though it has moved on, its passage left behind something we cannot measure, a sense of belonging to a galaxy that is not divided into separate worlds, but united by the same gentle flow that carries everything from one star to another. By the time 3I Atlas began to leave the solar system, the sun had already grown faint behind it, no brighter than a sharp point of white light among a sea of other stars. The warmth that had stirred it briefly was fading again, and the traveler was returning to the cold that had shaped it for most of its existence. Astronomers charted its path as it moved away, watching it slip quietly toward the direction of the constellation Lynx. Out there, beyond the outermost traces of the sun's influence, gravity begins to loosen its hold. The planets fall away first, then the comets, then the last drifting particles of dust that mark the edges of our home. Past that boundary lies the dark, and into that dark 3I Atlas continued, without hesitation. There was nothing dramatic about its departure. It did not flare or shatter or vanish in light. It simply grew dimmer each night, its fragments spreading farther apart, until even the most sensitive telescopes could no longer distinguish it from the background of stars. The final images showed only a faint streak of brightness, fading into invisibility. Yet even as it disappeared from our view, it remained moving, still following the curve of its hyperbolic path, still carrying with it a trace of our sun's light. That faint glow would linger for a while longer, a memory of the brief time it spent in our sky. When an object leaves the solar system, it carries something of us with it. Every fragment that passes near the sun collects sunlight on its surface, and that light, once reflected, continues outward. It is weak and quickly scattered, but in the perfect darkness between stars, even a single photon can travel forever. The dust that escaped from 3I Atlas will continue to scatter those photons, drifting slowly through the galaxy, carrying a soft echo of our star into distant space. It is unlikely anyone will ever see that light again, but it will exist, spreading thinner and thinner, mingling with the light of other stars until it becomes part of the galaxy's quiet background glow. Astronomers who watched its departure described it not as an ending, but as a continuation of a story that began elsewhere. Its orbit will take it outward for millions of years, through the thin outskirts of our galactic neighborhood and into the wider spiral of the Milky Way. Along the way, it will pass near other stars, pulled slightly by their gravity, its path bending and shifting almost imperceptibly with each encounter. Sadie. Perhaps far in the future, it will brush close enough to another solar system to be drawn inward again. There it might shine once more, faintly warming under the light of a new sun, a visitor repeating the same story it once shared with us. The thought that it could one day be seen again, in some distant sky beneath the gaze of another civilization, is quietly moving. They might look at it and wonder, as we did, where it came from. They would trace its motion and find, as we did, that it carried the signature of a long, unbroken journey. And perhaps, as they measured its light, they would notice something slightly different about it, a faint pattern in its reflection that spoke of another star it had once passed. That trace would be the whisper of our sun, carried outward across the galaxy by a small broken traveler. In that way, 3I Atlas continues to connect us to the larger story of the Milky Way. Its journey outward is part of a cycle older than humanity, older even than Earth itself. Fragments from distant systems arrive here, linger for a while, then depart again, taking with them small pieces of our own light. Each crossing adds another thread to the web of connections that binds the galaxy together. The travelers move too slowly for us to see that web forming, but it exists, stretching from star to star, linking the beginnings of one world to the endings of another. As it moves away, 3I Atlas grows quieter. The sun's warmth has faded to nothing, and the silence of interstellar space surrounds it once more. But its departure is not lonely. It joins the vast company of other wanderers, fragments of ancient worlds drifting along the same invisible currents. Its direction may be toward the constellation Lynx, but its destination is less a place than a continuation of motion. It will keep going, carrying with it the faintest trace of our presence, a dusting of sunlight and the memory of being seen. And in that endless travel lies the beauty of all such visitors. They remind us that the story of the universe is not made of beginnings and endings, but of continuations. Everything moves forward, carrying a little of where it has been into the places where it will go. 3. Atlas is no longer visible, but it is still out there, still moving, a quiet traveler gliding through the dark with a thread of our light woven into its long and unbroken journey. Long after the last images of 3I Atlas had been recorded, its presence lingered in the thoughts of those who had followed it. It was gone, its light swallowed by the distance, but its story continued quietly in the background of human curiosity. The scientists who had measured its motion still ran their simulations, tracing the path of its fragments as they slipped farther away from the sun, predicting where they might be now and how they might look if seen again. They knew that, in all likelihood, no telescope would ever find it once more, but the idea that they had caught even a glimpse of it was enough. It had passed through our skies for a moment, and in that moment, it had reminded us of something we often forget, that the universe is not a still picture, but a flowing river, carrying everything along with it. Even now, 3I Atlas continues its journey through that river. It moves deeper into the dark, farther from the warmth of the sun and the thin dust of our solar system. Out there, beyond the edge of everything we call home, the stars begin to look different. Their light does not flicker or dance as it does through our atmosphere. It is sharp, cold, and perfectly steady, each one a small, unblinking fire. The traveler glides among them, silent and unchanged. It does not slow. It does not hurry. The forces that guide it are patient beyond all human comprehension. Its path is a line of gravity and time, a thread connecting the past to a future we will never see. Perhaps far in the future, it will pass near another star. It might brush through a new system, slipping close enough for the warmth of an unfamiliar sun to touch it again. Maybe it will leave another faint tail of dust, another soft shimmer in a sky no one on Earth will ever witness. And perhaps, on a distant planet orbiting that star, someone will look up and notice a small moving light and wonder what it is. They will ask the same questions we did. Where did it come from? How long has it been traveling? Has it passed through other skies before theirs? And in that wondering, they will share something with us, though we will be long gone. Curiosity itself will have crossed the space between stars. The echo that 3I Atlas left behind is not in the dust or the data, but in that sense of connection. Its brief appearance reminded us that the sky above us is alive. It is not just a backdrop for our small world, but a vast, living network of motion and memory. Every object that passes through it leaves traces that ripple outward. Those ripples can be as subtle as a change in brightness or as profound as a shift in understanding. When 3I Atlas entered our solar system, it carried with it the light of another world. When it left, it carried a little of ours. In the quiet balance of the universe, that exchange is how everything endures. There is something deeply comforting in that thought. The light we cast into space today will travel on long after we are gone, brushing across comets and asteroids, scattering through dust clouds, reflecting faintly off worlds we will never see. The light of our sun will continue outward until it meets the edges of other systems, mingling with the light of other stars, becoming part of the galaxy's soft glow. In time, that light will reach even the distant place where 3I Atlas now travels. It may touch it again, not in warmth but in acknowledgement, as if saying goodbye from across eternity. When the story of the visitor is told, it ends not with an ending but with a continuation. It is still moving, still carrying the same silence, still marking the invisible highways that link one star to another. Its visit taught us to look more closely, to listen for the quiet passages of other travelers, and to remember that even in the vastest distances we are part of the same unfolding. The universe does not forget. Every path crossed, every reflection of light, every gentle encounter between worlds leaves an imprint that endures. 3i Atlas is one of those imprints. It may never return, but its memory will. It lives on in our awareness of what it revealed, in the questions it stirred, and in the way we now watch the night sky a little differently, knowing that among the countless stars, there are always travelers on their way from one home to another. Somewhere out there, the faint remnants of 3i Atlas continue to drift, and though we will never see them again, we know they are there. They carry sunlight, starlight, and the quiet weight of a moment when our world looked up and noticed. The echo it left behind is not loud or grand, but it does not fade. It moves through time the way the traveler does, slow and steady, carrying with it the same enduring message that everything passes, everything connects, and that even the briefest light in the darkness can remind us of how deeply we belong to the stars. And so, the quiet traveler drifts away again past the last faint pull of the sun's gravity, back into the infinite dark between the stars. It came without a sound and left without a trace, a brief flicker of wonder across the long night of the universe. Perhaps right now, it's already 1 trillion kilometers away, carrying a little glimmer of our sunlight on its fractured surface, the faintest memory of its time here. When you close your eyes tonight, imagine it's still moving, not lost, not lonely, just continuing, because that's what the cosmos does. It flows, it never stops. Every atom of you, every breath you take, was once part of that same great wandering stardust, drifting until it found a place to rest. So let your thoughts drift too. Let them travel where gravity can't reach, across the dark, quiet spaces between stars. The universe is vast, but it's gentle to those who listen. Sleep well, dream softly, and may your dreams be full of quiet visitors and starlit skies. Good night, traveler.